Welcome to the lecture series of Basic Electrical Engineering. So we are seeing the module 4, that is Electric Utilities and Production. Today we are going to see a quite interesting topic, that is the basic elements in electrical wiring, that is service mains, meter board, distribution board, and we are going to discuss about the concealed conduit wiring. So what is it? So here, first we are going to talk about the service mains. So I think in the previous discussion, we might have learned about how the electrical power is generated, transmitted, and it is reaching the distribution side. And the distribution, secondary distribution is coming up to the pole outside our house. From that, how we are tapping. So here, the conductor which bring electricity from the nearest pole carrying the secondary distribution system to the consumer premises or known as service mains. I think we might have tapped the power from that poles or maybe underground cables. So that is known as the service mains. The length of these lines run from the pole to the meter board of our premises. So I think we know that from the meter board, we'll put one pipe or something to get the tapped power. For all domestic requirements, only single phase supply is required, and hence two wires are used for service mains, one for phase wire, other for neutral wire, and along with it we may add some earth wire also, the third conductor. Normally ACSR will be used as the conductor for service mains. There is nothing but aluminum core steel reinforced conductor is used as a service main. There are two types of service mains. So service main is nothing but up to the pole, the EB will take care. After that we should take care. From that we will tap our conductor. So that is known as a service main, and it will be entering into the house by means of overhead service system or underground service system, whatever it may be. So here you can see service drop, it may be underground service system. From there we will put a fuse for phase side and neutral side. I think in the next module we may be seeing this power connection. So it is nothing but phase neutral. That is 1, 2, 3, 4 connection will be there. So this is our meter board, that is kilowatt hour meter. So these two lines are the inputs and these two lines are the output. It will be going for the main MCB. So main MCB is nothing but miniature circuit breaker. So this is in general known as the distribution board. This is known as the meter board. So meter board will be along with the fuse and the energy meter, single phase energy meter or kilowatt hour meter. So this will be the distribution board. In the distribution board, from the main MCB, it is connected to individual MCBs. So I think these MCB may go for the kitchen. So it will be having the lighting load plus maybe sometimes it may be having the geysers. So this will be going for the bathroom. It will be controlling the geysers. This may be for bedroom 1 and bedroom 2. This may be for the hall. This may be for the lobbies. So along with that, the neutral will be there. So it may be a Paka 2 BHK flat. Along with that, the earth connection will be the neutral. There is no control will be there. It will be fed directly, but phase should be controlled through this MCBs. So this is known as the distribution board, or it can be said also the sub-circuits where electrical power is transferred. So this is the one type of or next type of overhead system. Here you can see the line is tapped, so it is quite little bit clear. So it is coming to the meter. So this is the kilowatt hour meter. From that it is going to the DP. DP is nothing but double pole. Here you can see pole 1, pole 2. So SP is nothing but single pole. So from the double pole, it is going to the RCD. RCD is nothing but residual current device. Now it is also known as MCBs or ELCBs, whatever it may be. From that, it is going to the all sub circuits. So maybe 1, 2, 3, 4, whatever the room may be, there may be 8 sub connections are there. Along with that, we'll have the earth wire, which is already earthed. This also will take, and this is the neutral sub-circuits. So each sub-circuit will go for each room, each has a separate control. So here you can see the various ranges. So this is the total load. So here you can see 63 amps, but it is split into equally. So 20, 20, maybe 16, 16, 10, 10. So along the use of, according to the usage, the ampere is divided. So this may be going for the lighting loads. This may be for the heating loads, that is geysers and boxes. So such type of devices we will be using. So as we discussed already, here it will be 230 volt. So everywhere it is a 230 volt, the input will be generally 230 volt. And here two number of 16 wire will be used. Maybe copper and PVC wire combination or PVC cable combination will be used for this purpose. So this is a quite easy understanding. This is how the power is coming from the pole to your home distribution board. There will be a board in your entrance, maybe at the entrance of your home. So it contains of these components. So this is generally known as the service mains. So the next one, what is electrical wiring? So electrical wiring refers to the insulator conductor used to carry current to the associated device. As I told, from these wires it has to go for kitchen, it has to go for bedroom, everywhere it has to be. So for that we need a wiring system. So domestic electric appliances like light, fan, washing machine, water pumps are connected to the supply through insulated wires which are controlled by switches. So this is nothing but the wiring diagram. So how we can give? So this is the one more simplified structure of this previous diagram. So this structure can be simplified into this one. So service means single line diagram, which we learned in the module. Sorry, same module. First topic was that one, single line diagram of the power system. Big power system can be done in a single line. Similarly, we are going to make it as a our service main wiring also in a single line diagram. Here you can see it is a meter. Circuit breaker is nothing but MCB. Distribution board also group of MCBs. So what are the components? So what is required? So here in the service means we require a fuse, the input terminal of the energy meter with fixed wooden or galvanized iron or mild steel. So these are used because it won't rust. Galvanized GI pipe won't rust easily. MS is nothing but very strong. I think many people know that MS is nothing but mild steel. The main switch, which is used to switch on or off the supply to the building, is provided next to the energy meter. That will be naming it as a main board. And the output terminals of the energy meter are connected as the input terminals of the main switch. So that we know. So the output terminals of the main switch are connected to the distribution board. The main switch will be maximum, that ironclad double pole switch, ICDP, one switch that we will be seeing in the next picture. So we'll get more idea regarding that. So what is ICDP? And also in the distribution board, there is a rectangular box with several wooden or J pipe. In addition, there will be two bus bars, that is wires. Bus bar is nothing but wires. What we are using is known as bus bar. So one is the phase, other one will be the neutral. The domestic load is distributed to various sub-circuits from the distribution board. As I told already, one will be going for kitchen, one will be going for the bedroom, one will be going for the hall. So it will be distributed. So here, this is the ICTP. So what we told. So here it is a triple pole. Usually we using ICDB. So ironclad double pole switch. So here it will be only two, not the three. Here it is a triple pole. Only one on ironclad will be there. So this may be the main box. This may be the PVS capping, which is used for laying the PVC wires inside, and this is known as the MCB. This is the distribution board. So this is a box. I think this and all we might have seen in real time, but we are showing for your better understanding. And these are all the bends. This also we may be using for our purpose. Then there was various type of sockets. In Indian type, it will be in the round, not in square. Here are this is for cables, telephone cables. Okay, so these are all the various type of sockets. This is a one-way switch. Here we will be having one input, one output. I think we might have done in the lab. We'll give the power supply in. This is the power supply out. This is the two-way switches. This is for staircase wiring. I think this will be seeing in the next topic. This is the intermediate switch. This will be used for belling. So TikTok type. And this is the flush type switches. This is also used for lighting purpose. And this is the bed switches. This also we know. So these are various type of holder. This is the baton type holders. This is the pendant type holders. What is the hanging? And for hanging purpose, we'll use the ceiling rows. And this is the aluminum wire. From the color itself, you can identify it. It is a aluminum wire. This is the copper wire. So copper will be, it is a little bit orangish. So it will be a little bit white or silver color. So based on this, we can differentiate the both type of wires. So what are the factors affecting the choice of wiring system? So what are all the factors to be considered? The first one is durability. The type of wiring selected should conform to standard specification, so that is durable without affecting the weather conditions. So it should be standard. We should not use this normal, I think twisted cable wires you might have been seen, that we should not generally use in junction boxes and all. It will be it is otherwise known as silk wires, that we should not use. It is not safe only. So it should be durable. Second one, safety. The wiring must provide against leakage. There should not be any leakage or fire hazards or shock, something. And also appearance, it should be neat with appeal for the interiors. It should be looking neat. The wire should not be hanging here and there. And cost should be very less. It should not be more expensive. And accessibility, the switches and plug points should be accessible, easily accessible. So if you're entering into the room, at the entrance there should be the switches, not at the end or near the windows. So it should be easily accessible, so that we have to design a wiring according to that. And the maintenance cost should be minimum, it should not be more. And it should be protected from mechanical damages also. So these are all the requirements for electrical wiring. So generally, so as per the usage, it is classified as domestic wiring, commercial wiring, and industrial wiring. So we are going to see about the domestic wiring based on the consumer's building. We are categorizing it, but actually, what are the types of wiring that we are going to see it? Before that, what is the domestic wiring? So this is the reverse type of thing what we seen before. So this is the sub incoming cable. This is the energy meter, and this is the main switch. From the main switch, it is given to the distribution board. From the distribution board, it will be going to fan circuit, power circuit, and lighting circuit. So simple diagram for the consumers. So here is one more same. Will be always. I think we might have discussed in the class also. Always will be using the parallel connection, not the series connection, because if you use the series connection, the voltage will be shared. But in the parallel connection, the current will be shared. So that we are using the same connection. So this is the main main fuse here. It is here. This is the meter. This is the main switch. From that, it is going for various switches. So this is the earth connections. This is quite simple and easy to understand. And generally, based on the according to construction, how we are classifying the wiring. One is the CLET wiring. Second one is CTS or TRS wiring or batten wiring. This full form we will see there. Then metal sheathed wiring or lead sheathed wiring. Next one is casing and capping. Next one is the conduit wiring. So first we are going to see CLET wiring. CLET wiring is nothing but, so it is a type of wiring in which insulated conductors, usually vulcanized Indian rubber, supported by porcelain or wooden cleats are used. So here you can see this is the wire in that wooden cleats are used. So here the cleats have two halves. One is the base, other is the cap. So here you can see the base, other is the cap. So and that the cable is placed in the grooves. Here is the groove, here the cable is placed, and it is uh, both are fixed securely on the walls by 14 mm using long screws. Okay, so here you can see the screws. By means of the screws, it is placed, both are placed inside, and the clips are easy to erect and fixed within 4.5 to 15 centimeter apart, and it is very good for temporary and the appearance will be a little bit okay. So this is the type of clit wiring. Here you can see. So this is the base. Here is the cap. Here you can see the grooves. In the grooves there is the wires. So this is the other view of the this thing. It may be porcelain, made up of porcelain or some wood or maybe plastic also. After the wire connection, you can see this is the board. Here lamp is there. Here you can see. So this is the wire connection going to the lamp. So this is the type of clit wiring. These type of wirings now we are not using because of this odd appearance. So what is the advantage? It is easy to install. Materials can be retrieved for use. Flexibility for inspection, modification, and expansion. We can do it because it is a temporary thing, and relatively economical. Nothing here we are going to spend. Skilled manpower not required. Yes, obviously just screwing it. And what is the drawback? Appearance is not good. As we discussed already, it will be looking odd. Open system of wiring requires a regular cleaning. This is quite important in where the dusty atmosphere is there, and high risk of mechanical injury. In case of you are doing any repair works, it will be get easily affected. Next one is CTS or TRS or batten wiring. What is CTS? It is cable tire sheathed or tough rubber sheathed. So here we are replacing it with a rubber. So here you can see it. So what is its characteristics? In this wiring, wire sheath is tough rubber or used with quite flexible. Tough rubber is used and clipped on a wooden battens with brass clips. So you're using some type of clips to make it fixed on it. So this we may be using some 30 years before, such type of wiring, batten wiring. And these cables or moisture and chemical proof, because over there we are putting a tough rubber, and suitable for damp climate, not suitable for outdoor use in sunlight, because due to heating and cooling effect it is not suitable there, but inside a damp climate we can use it. And the TRS wiring is suitable for lighting in low voltage installation. This is very very important, only for lighting we can use it. Here you can see the insulated wires are there. Okay, so over that, here you can see this is the cable. So here is the batten. Above that some VIR, VIR, that is vulcanized Indian rubber or cable tire sheet we are using, and we are clipping it. Here you can see a clip, like belt it is. So these clips are used. So here also you can see the clip. So the wire will not move. So here you can see the cable will be there. Above that the VIR is there. Above that the clips are clamped in the batches. So this is a old type wiring. So this is also little bit looking odd. So here is also installation is easy and durable, low risk of short circuit, cheaper, quite cheap chasing and capping, and gives good appearance if it is properly erected. So this is somewhat okay. So not looking odd, but danger of mechanical injury, fire hazard is there. It is exposed to direct sunlight, and also skilled workmanship is required. So making it pinned, it requires a skilled workmanship. So next we are going to see about the metal sheath or lead sheath. So it is similar to CTS, what we see seen in the previous one. There is a tough rubber. So here conductors of two or three are individually insulated and covered with the common outer lead aluminum alloy sheath. So outer in the cable we are using the sheath, same sheath can be used. So this gives the protection against dampness and mechanical damages. And it also provides leakage, so protection against the leakage current, and this can be fixed by means of metal clips or wooden battens. It is quite expensive and it is also used for low voltage, so some precaution has to be taken while doing this. So here it is similar to the previous one, so it should react with the sheath. So the cables and batten should be kept both on the same place, and lead sheet should be properly earthed to prevent the shocks. So in the previous case, only rubber we are using, it is exposed to sunlight or exposed to temperature or exposed to mechanical injuries. To overcome that, we are providing a metal sheath, lead sheath. So it is a conductor. So it should not be in contact with the electrical wires inside. So it should be properly earthed. And cable should not run in the damp places in or chemicals are there. So there we should not install them. So it is easy to install, and it is good, it is looking good, and it is highly durable and suitable in adverse climatic conditions, and provided with the joints, but requires skill labor, very expensive because lead is costly. Whether we are putting a lead sheets unsuitable for chemical industries, because lead PB will react with the chemicals. So next one is the chasing and capping. It is the type of wiring which we may be using some 15 to 20 years back. Here the insulated wires are laid inside the rectangular teakwood or PVC boxes having grooves inside. It may be rectangular strip of wood or chasing or capping. So the capping may be screwed together every 15 centimeters. It is attached to the wall and it is used for installation of domestic. Here you can see. So this is the wire. So above that a wooden casing is there, above that a capping is there, we are putting over it. So this is the wire, above that we are putting it, maybe PVC also we can use. So this is the type of wiring. So compared to the previous types, so it is little bit okay, fine, but this type of wiring now we are not using, we are in a well advanced stage. Here cheaper than lead sheet because their lead is too costly, and it is also known as conduit wiring, provides good isolation between the conductors. So phase and neutral is isolated and easily accessible from inspection and repairs. You can easily access for repairs. And the wires are not exposed to atmosphere. That is very, very important. It's highly protective. Insulation is less and affected by dust, dirt, and climatic conditions. So here these wires are not exposed. So it is less affected by this dust, dirt, and climatic condition, and highly inflammable because wooden is flammable. And usage of unseasoned wood get damaged by termites. We know, right? So holes will be there. So frequently we have to maintain it. So next is the recent one we are seeing the conduit wiring. It may be open conduit or closed conduit. For that, we are using the PVC pipes, polyvinyl chloride, or VIR, vulcanized Indian rubber. So these PVC pipes inside, we will be having the wire, and which gives the protection against mechanical injury and fire also. This was embedded inside the walls now and supported by the cover. That is known as concealed wiring or surface conduit wiring or open conduit wiring. So the conduits are buried inside the walls and wooden gitties. So this is now we are using with the steel wires also for public buildings, industries, and residents also. Here you can see there is a PVC pipe. This is known as conduit. Previously we were using the metal. It is quite costly, so we went for PVC. Inside that insulated conductor is there. So this type of wiring is known as the conduit wiring. I think we might have done this in the lab also. So this type of wiring I think you might have done in the lab. So this is some 10 years before this was frequent. During up to 2000 we were following the same year, we were using the bend and all. This is made up of metal, this is made up of PVC. Here you can see T joint, and somewhere you will use the L joint also. From switch it will be going to the PVC pipe. So this is the concealed conduit wiring. Later we want to lay the wire like this because it appearance is not good, because in the wall if more pipes are there it won't be looking good. So what we done, we have embedded into the wall and we close this wall. So this is looking, so before putting the terrace slab, the terrace we will be putting the slab, we will lay the uh, terrace iron, that is steel. We will lay this steels. After that we will embed this PVC pipes. Wherever the junction box is there, there will be the points, maybe lighting point or fan point will be there, and at the end of the wall there will be droppers. So here you can see there is a droppers. So these are all the droppers where we can put the switches. And this is the open conduit, this is the closed one. If you put a cement over it, so it is looking good. After that the finishing will be like this. So where is the connection we don't know, but the appearance is very good. So we can use it for the modern utilities and modern houses also. So this is the difference between the open wiring and concealed wiring. Here you can see from the switch box, the PVC pipe will be moving in the walls throughout. But here it is quite simple. No pipes are moving in it. So what is the advantage? No risk of fire and good protection against mechanical injury. The lead and the return wires can be carried in the same tube, no problem in it. Earthing and continuity is assured. Waterproof and troubleshooting is very easy. Shockproof with proper earthing and bonding. Durable and maintenance free. It gives a very good appearance, and it is very expensive system of wiring, requires skill. So we have to pull the wire once the top, if they lay the wire in the concrete, later you have to pull from here to here or here to here. That is a skillful task. It requires a trained person. For that only we are going for people who have done the apprenticeship in it, maybe license holders. Erection is quite complicated and time consuming also, as we discussed already. Risk of short circuit under wet condition. So there may be sometimes in case of in the terrace some water stagnation is there, there is a chance of short circuit. So this is about the service mains, types of wiring, and the installations what we have done in the home with the distribution box. Thank you for watching.